Each year, the U.S. beer industry sells more than $100 billion in beer and malt beverages. There are 7,180 brewery facilities in the U.S. consisting of large breweries, regional breweries, microbreweries, and brew pubs. Our focus was on large breweries with an emphasis on Anheuser-Busch's brewing facility in Jacksonville, Florida. The production of beer in large breweries consists of 4 main stages: brewhouse operations, fermentation, aging, and packaging. Once the malting process is complete, the brewing process begins with the malt being transported to a brewery and moved into storage silos. Malt mills then grind the malt into malt flour, which is transferred to milled malt hoppers. From the milled malt hopper, the grain enters the last stage of the brewing process, where it is combined with hot water and fed to the mash tun, where the mixture is heated to convert grain starches to fermentable sugars. After the brewing process, the mashing process begins. There are 3 principal mashing processes, which are double mashing, decoction, and infusion, but most breweries use only one. The infusion process mixes the malt with hot water to maintain a temperature of 65 degrees Celsius to 75 degrees Celsius until all the starch has been converted. Even though mixing, heating times, and temperatures can vary brewery to brewery, the finished product is a grain slurry called mash. To start the infusion process, mash from the mash tun is pumped to a lauter tun, which is a straining tank that separates insoluble grain residues from the mash. The mash enters the lauter tun through a false bottom where the insoluble grain residue settles. This insoluble residue acts as a filter, along with other agents such as polypropylene fibers, for the mash as it enters the tank. The mash product that is kept is called wort, and the spent grain byproducts from the lauter tun are sent to the holding tanks, where the grain is sometimes dried and sold as animal feed. The wort is transferred to a brew kettle where it is boiled for 90 to 120 minutes. The purpose of the boiling is to stop the starch to sugar conversion, sterilize and concentrate the wort, precipitate hydrolyzed proteins, and cause chemical changes that improve the flavor of beer. The characteristic bitter flavor of beer comes from hops, which are high in isoacids and are added during the boiling process. After brewing, the hops are separated from the hot wort by straining, and the hot wort is pumped into a large settling tank where the remaining insoluble material known as trub settles out. The trub is transferred to spent grain holding tanks while the hot wort is pumped into a cooling system. After cooling, yeast is added to the wort, which is then pumped to fermenters to begin fermentation. Primary fermentation is the second main process stage in the production of malt beverages and is a biological process where yeast converts sugar into ethanol, CO2, and water. Fermentation takes place in large tanks that can be open or closed to the atmosphere. The size of the tank varies from brewery to brewery, but tanks typically hold more than 1,000 barrels for medium to large breweries. In fermenters, yeast can ferment either at the bottom or the top. Bottom fermenting yeast usually rise to the top of the fermenter initially before moving to the bottom during rapid fermentation. The beer is run off the top of the fermenter when fermentation moderates, which leaves the bottom fermenting yeast at the bottom of the tank. Top fermenting yeast rises during rapid fermentation, so it is generally skimmed or centrifuged off the top during moderate fermentation. The type of yeast used and the length of the fermentation process varies among breweries and types of beer produced. Secondary fermentation, or aging, is the third main process stage in the production of malt beverages. Waste yeast is usually removed from the liquid before the liquid is pumped to aging tanks where small quantities of wort is mixed into the liquid. The liquid is then stored at low temperatures until the aging process is complete. After the beer is aged, solids are usually removed by filtration or centrifugation with earth filters. The beer is then pumped to the beer storage tanks and then to the packaging facility. The last process stage in the production of malt beverages is packaging. Packaging facilities typically have several canning and bottling lines along with keg filling operations. Depending on the facility, some beer is pasteurized after canning or bottling, while other facilities package non-pasteurized products using sterile filling lines. The final steps after individual packaging is labeling, packaging for distribution, and shipping. Each stage of the brewing process is responsible for different emissions, which include VOCs, PM, CO2, and other gaseous emissions, with ethanol being the primary VOC produced. Emission rates from large breweries vary greatly depending on recipe, time, and temperature. Other compounds emitted include aldehydes and ethyl acetate. VOC emission sources include brew kettles, lauter tubs, hot wort settling tanks, fermentation, secondary fermentation, bottling, and waste beer handling. Most operations before fermentation are the source of several types of VOCs. Operations post-fermentation emit mostly ethanol, but can also emit small quantities of ethyl acetate and various aldehydes. Fermenters are a source of ethanol, VOCs, and CO2, with CO2 being recovered for internal use. Particulate matter emissions from breweries include grain malting, grain handling, processing operations, brewhouse operations, and spent grain drying. It is important to control pollutants released during the brewing process, as leaving them unattended can result in harmful effects to our environment and human health. For example, VOCs are a significant problem because of their tendency to react with NOx under sunlight and form ground-level ozone. Ground-level ozone is known to reduce lung function and harm lung tissue in humans, as well as impair physiological functions in vegetation that is important to many ecosystems. Carbon dioxide is a greenhouse gas that is emitted throughout the brewing process. Greenhouse gases contribute to climate change because they absorb radiation from the sun, which in turn contributes to the slow rise of the Earth's temperature. CO2 can also contribute to the breakdown of the ozone layer. Particulate matter can reduce visibility and cause smog because high concentration of particles can scatter and absorb light. It can also damage buildings and other materials, cause corrosive and erosive damage to structures, and even alter local weather. Airborne particles can impact human and animal health by absorbing certain chemicals and intensifying their effects by holding them in the lungs for extended periods of time. Ultrafine and fine particles can easily penetrate the respiratory system and transmit their chemical doses to different organs. Particulate matter may be treated using a fabric filter. In a fabric filter, the gas flows into and through several parallel filter bags, where the dust particles from the gas are retained by the fabric with the help of the dust layer previously formed. A fabric filter operates on the same principles as a vacuum. Fabric filters are also useful in grain handling operations, such as unloading, conveying, milling, and storage. They generally have high efficiencies, but depend on the media that the filter is made from and may have some limitations based on material properties. To treat low concentrations of ethanol, a wet scrubber and incineration are both options, as well as carbon adsorption. A wet scrubber collects particles by direct contact with a liquid, usually water. Collection efficiencies vary with scrubber type and size of the particulate matter. Collection efficiencies can range from 40 to 60% for simple spray towers to greater than 99% for Venturi scrubbers. Wet scrubbers are not very practical for ethanol collection since efficiency is partially based on pollutant concentration, and the ethanol concentrations in fermentation rooms are typically very low. Another control device for ethanol is an incinerator, which operates at high temperatures to combust organic substances and waste materials and converts the waste into ash, flue gas, and heat. Incinerators also have the potential for very high efficiency, but the high fuel cost is a major disadvantage. For large breweries, incineration is not practical because the pollutant concentrations are too low. Carbon adsorption is also useful for removing ethanol by using activated carbon, which refers to the increased internal and external surface area of the carbon. Activated carbon absorption removes low concentration gases and vapors from an exhaust steam by adherence of these materials to the surface of porous solids. Most industrial grade carbon comes from bituminous coal, but activated carbon is tailored for specific end use, considering both raw materials and control of the activation process. The major utility costs of adsorber operation are steam, electricity, and cooling water costs, with the disposal of wastewater also being considered. Carbon dioxide can also be controlled using activated carbon beds. Organic impurities collected by the activated carbon bed are typically released into the atmosphere. Efficiency of activated carbon adsorption depends on the type of pollutant and the type of activated carbon used. For concentrations of 500 to 2000 ppm, efficiency typically ranges from 95 to 98% for an effective installation. Gas adsorption is commonly used for industrial applications such as odor control, recovery of volatile solvents, and the drying process of gas streams. The Anheuser-Busch Brewery in Jacksonville, Florida operates under a Florida Title V air permit, which was established under a 1990 amendment to the Clean Air Act. Title V air permits only apply to major sources or sources that emit or has the potential to emit any criteria or hazardous pollutants at levels equal to or greater than the major sources threshold. The major sources threshold varies depending on the attainment status of the geographic area and the criteria pollutant in which the facility is located. The EPA monitors particulate matter under the National Ambient Air Quality Standards. Overall, large breweries consist of numerous processes that release air pollutants into the environment. These pollutants can affect both human and environmental health, so it's crucial to control them to the best of our ability. So we thank you for watching and hope that the information shared can also be applied to other industrial processes similar to large breweries. From all of us in Breathe Easy, cheers!